Hello everyone, welcome to my workshop. Today we will learn how to detect shapes of objects by finding their contours. Contours are basically outlines that bound the shape or form of an object. So we will be detecting multiple shapes and how many corner points each shape has along with its area. I upload videos on a weekly basis, so don't forget to subscribe and hit the notification bell if you would like to see more of these videos. So let's get started. So here we have our code from our webcam video where we are running the webcam and displaying each image frame by frame. We are importing our libraries, which are CV2 and NumPy. We are initializing our camera settings, and then we are reading each frame and then displaying it using the imShow function. Now, what we are going to do now is first we will convert our image into grayscale. Now, before we do that, we want to add a little bit of blur. So in order to do that, we will use the Gaussian blur function. Now we have discussed that in one of the previous videos. So here is the function. This is our image blur, and we are using the Gaussian blur function with a kernel of 7 by 7, and we are converting our image into a more blurred version. Now once we have done that, we are going to convert it into grayscale using the grayscale function, which is CVT color, and we are inputting our blurred image, and then we are converting it into gray from BGR. So before we go any further, a good practice would be to visualize what we have done so far. So if you remember, a while ago I wrote a function for stacking images together. We want to display all of them side by side, not in a different window. So what we can do is we can copy that function. I will have the link of that function in the description. So here is that function. We just have to input the scale and the array of images that we want to stack together, and it will stack it for us. So in our case, we want to stack our images. So we will say image stack is equals to stack images, and we will give the scale of 0.8, and then we will give our images, we will give an array of images which is img, and then we have img blur, and then we have img gray. So, and instead of displaying the image, we are going to display the image stack. So let's run that. So here we have the three images. We have the original one, and you can see there's a little bit of blur being introduced, and then we have the grayscale image. So next we are going to use our Canny edge detector to detect the edges in the image. Now, if you remember, the Canny edge detector has two thresholds, and what we need to do is we need to move them around until we get the right values. So in order to do that, we will use track bars. So let's introduce the track bars. So we will need the name of the window, we will resize the window, and then we will introduce our threshold 1 and threshold 2. So here is the name the window parameters, then we have the resizing of the window, and then we have we are creating the track bar 1 with threshold 1 and track bar 2 with threshold 2. Now this empty is basically the function that will be called whenever there is a change in the value. So we don't want to do anything over there, so we are defining a function empty, and we will just pass it. So now that we have that, we will write our Canny edge detector. So in the Canny edge detector, we have the Canny image. Then using the Canny function, we will add our gray image, and then we will define our threshold 1 and then threshold 2. Now these threshold values will be coming from our track bar. So we will say threshold 1 is equals to something and threshold 2 is equals to something. Now this something we will define by getting the position. So cv2.get track bar position of threshold 1 in the parameters window, and the same thing for threshold 2. So we will write here threshold 2. There is a spelling mistake somewhere. Threshold. Okay. So if we run it now, we should have our values. All we need to do is we need to display it. So let's remove the blurred image and we will display our Canny image Canny. So here we have our images that are the original image, the grayscale image, and now the Canny image. So we have our track bars. If we move those around to the minimum, we will be able to see all these contours. So we want to filter it out until we get a low amount of noise and the contours we require. So 23 and 22 seem to be a good value. So we will go up, and in our initial value we will say 23 and 25. What was it? Or 20? I don't remember. Okay, 23 and 20, let's say. So let's run it again, and yeah, pretty good. Now if you see here, we are getting some overlaps and then we have some noise as well. So one way to remove that is using the dilation function. So to introduce the dilation function, we have to define a kernel. So the kernel can be defined by the numpy array of ones. So we are declaring as 5 by 5, and then we are declaring our dilation image using the dilation function. We are introducing the image Canny in the function, and then the kernel, and then we need the number of iterations. So our iterations are 1. So let's display the dilation image, img dilation. Let's put in a new row, and we will say img dilation, then again img dilation. We're just doing this because we need 3 images in each row. Okay, so here you can see the results. So now we have a much better square, or the outer what do you call the edges. So now we can send it to our contour function. So let's make a new function for the contours, because we will have to write a few lines of code. So let's define a function by the name getContours. Now in this function we are going to require 2 images. One will be our input image and the other one will be our output image. So here we have the input image that we will find the contours from, and in the second one we are going to write down our detected contours. We are going to display our detected contours. So here we are going to write the function of contours. So here we have the find contour function, and we are sending our image, and then we have a parameter that is retrieval method. So retrieval method, we have 2 main types. We have a few types, but I have found that two of them are really essential. One is external. In the external method, it retrieves only the extreme outer corners, outer contours. And there's another method by the name tree. In the tree, it retrieves all the contours and reconstructs a full hierarchy. So if we run this, for example, before we do that, let's see the approximation as well. So the last parameter is our approximation. Here we are getting all the stored contour points, but if we use the other one, which is simple, there's another one by the name simple, that will compress the values and we will get lesser number of points. So we are going to write it as none so that we get all of these points. And now to display them, we are going to use the draw function. So we will draw our contours on our image, and for that we have our image contour. So our contours are basically coming from here. So we will copy this and add it to our contour function, and then this is our color, and this is the width of our boundary. So let's run this and see the output. So what we will do is we will call our function. We will say get contours, and we will input the image dilation, and we will say we have image contour for displaying the output. Now, but we didn't define the image contour, so we need to make a copy of this in the beginning. So we will say image contour is equals to image copy. So now we will just replace image dilation with image contour. So let's run that, and there you go. So now we have our contours that are displayed nice in a purple color, and we have some noise as well. So we will see how we can remove that. So let's get back to our function. We can detect the area of each contour, and based on the area we can remove all the contours that we are not interested in. So in order to do that, we will need a for loop so that we can loop through the contours. So we will say for CNT in contours, so these are all the contours, and this is one of the contours that we are referring to. So we will say that we need to draw this contour only. So we will take this function and we will remove that, and we will put it down here, and instead of contours now we will write CNT. And now we will look into the area of this contour. So for that we have the function. We will say area is equals to cv2 dot contour area, and we will give it the contour, and this will give us the area of this contour. So we will say that draw this contour only if the value is above a certain amount. So we will say if area is greater than, let's say 1000, then you should draw this. So let's run that, and there you go. So now we have reduced the noise by using the area. So next what we can do is we can actually find the corner points. So in order to do that, we need to first find the length of our contours. So for that we have the arc length function. So here we will say our parameter is cv2.arcLength, and we will give it our input, the points of our contours, and this true basically means that the contour is closed. Then this will give us the value of the length of the parameter, and we will use this parameter to approximate what type of shape this is. Now in order to do that, we will use the approximation of poly method, and we will input our contour, and we will give it a resolution, and then we will define again that this is a closed contour. So this approximation array will have a certain amount of points, and based on these points we can determine whether it's a square or a triangle or rectangle. So we will print out this approximation. So we will print approx, and this should tell us the number. Okay, so here we are getting all these points, but what we are really interested is the number of points that are in this array. So if we do the printout of the length, then we can see we have 4, which means this is either a rectangle or a square, because we are getting 4 points. We have 4 corners, so that is pretty good. So next what we can do is we can create a bounding box, because the points might not be always in a square form, or we might need to circle around, or we might need to highlight the area of where the object is. In order to do that, we will use the approximation of bounding rectangle. So we will say our x and y, and then width and height is equals to cv2 dot bounding box, bounding rectangle, and then we will give it our approximation. So this will give us the x and y, and then the width and height of our bounding box, and then we can simply display it using a rectangle. So here we can write this. Let me see. Okay, so here we have a rectangle being drawn on the image contour, and we have the x and y as the initial points, and then x plus width and y plus height as the final corner of the rectangle, or the square, the bounding box. So here we have the color, which is 02550, which means BG, it is green, and then we have the width. So if we run this now, we can see the result. Now you might see that, okay, so we have the purple and the green, which is good. So this is our bounding box. So next, to wrap it up, we are going to display our values so that we can easily see the number of points detected and the area detected. So we will write the put text function, and we will display it on the image contour. We will say that our points, and we will define it with the length of approximation. So if we have 4 points, it will say 4, and then we are going to give it the initial position and the font and the scale, and then the color and the thickness. The same thing we are going to do with the area, and instead of the length of approximation, we will add the area, and this time we will just make it an integer so that we have nice clean values rather than decimal places. So if we run this now, we should get our points. So we have 4 points, and our area is 18,580 something. So the last thing we might want to do is filter the object based on area. So we want to introduce a track bar that we can move around and filter our area. So we will introduce the third parameter in our track bar, which is area, and we will give it initial value of 5,000 and the maximum value of 30,000. And then instead of this 1,000, we are going to say that we need the value of our track bar. So we will say our area minimum. So our area minimum is replaced by this 1,000. So now if we run it, we will have another track bar that we can move around, and we can change the minimum area required. So here you can see after around 19,000, the points, the object disappears. So let's try out some other objects. So here we have a car, and it's showing us 9 points and the area. And then let's try something else. Okay, here the area might be too small, so we will reduce it, and there you go. So now you can see we can detect multiple objects of different shapes, their bounding boxes, and the area of these shapes. So that is it for today's tutorial. If you like the video, give it a thumbs up, and don't forget to subscribe, and I will see you in the next video.